Hello everybody and welcome to another C++ tutorial for beginners. In today's video, I'll be covering vectors. Now a vector is a dynamically resizable array. This means that the vector can change its size, so unlike an array that is a set static size that cannot change, if you try to add more elements into a vector and it is not large enough, it will just increase itself. Now there's a lot of complexities involved with that, but anyways, we'll talk about them in this video. All right, so the first thing we're going to do here is include vector. So we're going to say include, if I can spell include correctly, not happening very well here, we will include vector. And just a note here, if you're ever noticing that for some reason I'm using some data type or object that's not working for you, make sure you have the include statement, right? So previously, I think we used maps and you needed to include that. We had used some other things you need to include as well. And sometimes like stuff kind of works, but then doesn't work. And anyways, just always check the include statement because that's probably like a pretty easy fix to a lot of problems you guys might be running into. Anyways, what is a vector? As I was saying, a vector really is just like an array, except it has a lot of extra functionality. So it is kind of wrapping an array and allowing this array to dynamically change its size. And when I say dynamically change its size, as I was kind of stating in the introduction, this means that we don't need to know how big the vector is when we first create it. I don't need to define that it's only going to have 5 elements in it or 20 elements or whatever. I can do that. There's options to specify how big the vector actually is, but I don't have to. And that also means that if I decide to add something into the vector and it's not large enough, it will just expand itself. I can also have the vector shrink itself so that any of the kind of extra space it's allocating for new elements, it no longer is using in our computer's memory. Anyways, it's best if I just show you a few examples. So let's say vector. We're going to define the type of the vector, which in this case is going to be int, and then we need the name. So in this case, say v1, and this is going to be equal to, and then just like an array. So 1, 2, comma 3. So now I've created a vector. You can see there are no problems here. And well, that is how you make a vector. So obviously you need to pick one type. You put it in the angle brackets, then everything in that vector must be that type. So there's all kinds of stuff we can do with a vector. First thing we can do is we can look at the position of different elements. Right? As I say, v1 at index 1. We can end L here. That's going to give us 2 because, well, that's index 1 of the vector. Index 2 will give us 3. And there you go. Now we can also look at the front of the vector. So I don't know if I need parentheses or not, but I believe I can do front. And yeah, that's going to give me 1. And then I think I can do back. And that is going to give me the end. So to get the start and the end of the vector, you can do the front and the back. Now I have a little cheat sheet on my kind of right monitor here because there's so many different ones to go through. Those are kind of the main ones in terms of accessing elements in the vector. So very similar to what you use for an array. Then we have the size. This will tell us the number of elements in the vector. So 3, obviously if I change this to like 4, now we have 4. I can also look at what's known as the capacity of the vector. Now this one, I'm going to do some kind of fancy examples to show you how this changes. Right now, the capacity of this vector is 4. But if I decide to add some elements to this vector, which I will show you how to do, you'll notice this capacity is not necessarily going to be the same as the size of the vector. So the capacity is how many elements it can currently hold, and the size is the number of elements it's actually holding. So if I decide to add an element to the vector, and the way I can do this is v1 dot and then push back. Now what this means is push an element from the back of the vector. So this is kind of equivalent to appending an element. So adding to the end of the vector is what this really means. And I decide to push maybe like 9 here. Let's see if the capacity changes. Notice that I added 1 element and my capacity increased not by 1. It increased actually by, what was the math there? By 4. It doubled the size of the vector. So now the capacity is 8. So let's actually add a total of 8 elements, or add a number of elements so that we get to 8. So if I do this now, I push 4 9s and then I push 1 more, then technically our vector should be of size 9, right? So now if I do this, notice that the capacity goes up to 16. So what's actually happening here is as soon as I add an extra element, and let's actually do this here. So when we add just 8, the capacity stays at 8. As soon as I add this 9th element, it knows that the vector is not big enough, so it doubles the size of the vector, right? That's kind of the pattern we're running into. Now we get 16. And so if we print out the capacity, and then we print out, sorry, we don't need 2 semicolons here. We print out the size of the vector. You see we're going to get 16 with the size of 9. So hopefully that's clear, but that is kind of how the vector works. It's just increasing the size of itself as required, and it's trying to do it by an amount where it's not going to have to constantly increase the size, because increasing the size takes a long time to do. There's a few more things that we can do with vectors here. So I was pushing from the back, but I also can pop from the back, or I believe push from the front. I'm trying to see if I have that. There's nothing for push for the front, but I'll show you how we can like add something to the front of the vector. Let's also see here again, just kind of scanning my cheat sheet. Okay, so I'll show you pop from back. So if I pop from back, what I'm doing is removing an element from the back of the vector. Now, when I say pop from back, I don't need to give any index or anything. And what this will do is return to me the element that was removed, and it will remove the very last element from the vector. But you'll notice what happens here. I'm going to add 4 elements in, and then I'm going to pop 4 elements off. And I'm going to print the size and the capacity at kind of each step here. So after we add all of the elements on, I'm going to look at the capacity and the size. I'm then going to pop off 4 elements, and then we'll look at the capacity and the size of the vector. So let's do this, and notice that we get 8, 8, and then we get 8, 4. And so the capacity of the vector did not change, even though we removed elements from it. And so that's something to keep in mind, that even if I say pop 1 more off of here, so let's actually copy this line and do this. Let's see what we get here. We get 8, 8, 8, 3. So the capacity is not going to decrease when you remove elements. It's only increasing. So if you want to decrease the capacity of a vector, and again, the reason why you would actually even want to do this is because you don't really want to have a vector that has like 1 element in it that's using a capacity of, say, 10,000 or something crazy, because in that situation, you're just wasting a ton of space. Your vector is kind of taking up this space in memory and saying, okay, I have this much room, and it's using that space. And so if you don't need to be using that space, you shouldn't. So if you remove a ton of elements from a vector, what you can do is shrink that vector. And the method to do this is shrink to underscore fit. Let me make sure that's the correct one. I think that's right. I want to make sure we're not doing this wrong. Yes, shrink to fit. That is correct. So if we run this now, oops, we need a semicolon. So let's add that. Notice that what we get now is 8833. And so it shrank the vector to fit the number of elements that were in it. So the capacity of the vector is equal to its size after we say shrink to fit. And so those are kind of the core methods for the vector. Now, the next things I'll show you, is to insert and erase elements from the vector. So popping from back was pretty straightforward. We were removing an element from the end of the vector. And so we would have removed these 4 9s, and then I guess actually the 4 after we removed all of that. So now how do we insert and kind of erase specific elements? So let's erase all of this. So we will continue in 1 second, but I need to quickly thank the sponsor of this video and this series, which is Algo Expert. Algo Expert is the best platform to use when preparing for your software engineering coding interviews. They have over 150 coding interview questions on the platform, which are taught by the best instructors and curated such that you are not wasting your time going through a ton of problems that you will never be asked in a coding interview. Anyways, check out Algo Expert from the link in the description and use the discount code TechWithTim for a discount on the platform. Okay, so the next thing I'm going to show you is how to insert and erase elements. Now, this is not necessarily super intuitive. To actually be able to insert an element, you need a pointer to the position of the element that you want to insert this element before. And so let's kind of look at this here. What I can say is v1.insert. And then if I wanted to insert at the very beginning, I would say v1.begin. And then I would say what would I want to insert, which is 5. And now if I see out v1 at index 0, let's just end L here, and I run this, notice that we get 5. So we inserted at the very beginning, right, the pointer to the kind of first element here, the element 5. Now, if we do this again and we do 7, this will now insert before 5. So now notice that we get 7 printing out there. Now, if we say v1.begin and maybe we add 1 to this, well, let's just see what's going to happen now. And yeah, let's see what we get when we print out v1 at index 0. Notice that we get 1, but if we print out v1 at index 1, we are getting 5, the element that we inserted at position 1. So before the element at position 1, which means that this element will be at whatever position we define here. And so that's kind of how this works. Now, this is not really the best way to go about doing this, like v1.begin plus 1. I haven't tested if what I'm about to do is going to work, but let's try this. Let's try v1 at position, and let's go with position maybe, yeah, we can do 0, and let's see if that actually works here. I don't think that's going to work. Yeah, no, that doesn't work. But if I try an ampersand here, and do that. Yeah, okay, so it still doesn't work. So we need to do dot begin, and then we can kind of add to dot begin to figure out where we actually want to insert this element. Now, unfortunately, I don't really like how this works. I wish that there was a way that we could do it just based on the index. Maybe there is a way to do it just based on the index. If there is, let me know, please, in the comments. But regardless, I'm going to show you now how we can erase. So to erase is a very similar thing. What we're going to do is say v1 dot erase, and then obviously we don't need to like put an element if we're going to erase one. We just need to put what element we want to erase. So in this case, we'll say v1 dot begin, and then this will erase the element that's at this position to the very first position. So if I do this, notice that we now get 2 printing out because we erased 1. Okay, so that's kind of all the core methods and functions I wanted to show you relating to the vectors. The next thing I'm going to show you is how we iterate through a vector. So I'm going to get rid of this erase here, and I'm just going to show you how we can do this. There's a few different ways. The first way is to do something like int I is equal to 0. I is less than v1.size. Notice I'm using the size, not the capacity. That's very important. Plus I. And then I do something like cout v1 at index I, and then end L. Okay, so if we run this, we get 1, 2, 3, 4, as we would expect. Now that's fine. We can go with that method, or what we can do is say auto itr is equal to v1 dot begin. We can say itr does not equal v1 dot end, and then plus itr. And then let's see what we get here. If we say cout and we cout itr. Now let's give a test here. Let's run this. Notice we're getting an error. No match for operator, blah, blah, blah. Let's see what happens now if we do an asterisk. So if we do an asterisk, notice how now we're actually getting the proper elements because we had to dereference this pointer so that this actually works. All right, so that's another way that you can do this. Again, this gives us all of the elements. Now let's just see what happens if I decide to insert an element in this vector. So I say, maybe after we do the first one, v1 dot insert. Let's insert at the beginning. So v1 dot begin. Let's insert 10. Now let's run this with the iterator. We need a semicolon. Okay. Now notice we get 10, 1, 2, 3, 4, and so all is working. All is fine. So yeah, that's how you iterate through a vector, and really there's not much more for me to show you. There is a lot of other methods and stuff involved with a vector that you can use with a vector. These are kind of the core ones. Again, this is what you would use when you need a kind of dynamically sized structure that can increase or decrease its size. Just be careful though when you're using a vector, because if you remove a ton of elements from a vector, you could be in a situation where, well, you have just a ton of space being used by this vector, and well, it only really needs to store like 2 or 3 elements. So anyways, with that said, I hope you guys enjoyed. If you did, make sure to leave a like, subscribe to the channel. I will see you in another YouTube video.